All right, welcome to a new topic about absolute value functions. Um, this is specifically talking about compound inequalities. So we're getting away from absolute value for the moment for this section and these videos, and learning something that we need to know before we can start to solve absolute value equations and inequalities. So before we can talk about compound inequalities, we need to think about the words and or. So let's look at these sentences. What's the difference in the meaning of these two statements? This summer, I want to go to Iceland and Australia. First sentence. Second sentence, this summer, I want to go to Iceland or Australia. So what's the difference in those? Well, the first one implies that I want to go to both of these places, both of them. The second one implies that I'm only going to go to one or the other, and either one would be okay. Okay. So now we're going to look at using those words and or, which are very small words but have big meaning in a math context. So true story, we're looking into ziplining for my sons, and we discovered that one of them isn't quite large enough to zipline yet, because here are the rules to ziplining. You must weigh a minimum of 50 pounds and a maximum of 270 pounds. So we see this word and. That means that both of these have to be true. You have to be a minimum of 50 pounds, okay, and a maximum of 270. So let's talk about this algebraically. So let's let x be the weight in pounds. Okay, so the first part of this sentence, or this requirement, is that you have to be a minimum of 50 pounds. So you could be 60 pounds, 70 pounds. Could you be 50 pounds? Yes, minimum of 50 means you could be equal to 50 pounds. So we want x to be greater than or equal to 50 pounds. But we can't stop there, because 300 pounds is greater than 50 pounds. But we have this other requirement that the maximum has to be 270. So we have to have an and in here. That weight has to be less than or equal to 270 pounds. So what we've done is change this scenario into two inequalities, and we have to use the word and. So let's talk about this, what this looks like out on a number line, and get some more a feel for what's going on. So on a number line, let's say here's 0. We'll just put 50 right there, and we'll put 270 out there. What would that look like on a number line? Well, we have to be greater than or equal to 50 pounds. So we can use that bracket because we can be equal to 50. And we go that direction. But we can't go forever in that direction, because this other requirement says that we have to be less than or equal to 270. That would be that direction. But we can't be less than 50. So that shows us that our solution, I'll kind of make this a little bit bigger, our solution lies in, whoa, that's a little bit big. Let's see if I can delete that little section there. That tells us that our solution is only between 50 and 270. And then we write that in interval notation. We say the interval of weight is from 50 to 270. So that's an and. That means both of these statements have to be true. You must weigh more than 50 and be less than 270, creating this shaded region. And that was the region where it was both true for the red, for greater than 50, and less than 270. Now let's look at an example with or. Okay, let's say that you can get a discount at the movie theater or on your dinner or whatever if you're under the age of 12 or over the age of 65. So let's define Y to be the age in years. So if Y is less than 12, can it be equal to 12? What does this say? If you are under the age of 12. If you're 12, you're not under the age of 12. So we have to be strictly less than 12, or if you are greater than 65 years old. So what ages? You can get a discount if, how old could you be? You could be 11, you could be 10, 9. Can you get a discount if you're 50? No. So what that looks like mathematically on a number line, here's 0, we'll just put 12 right there, and 65, about there. So let's talk about y is less than 12, and then we use that parentheses, and because we can't be equal to 12, and we go that direction. But can we be less than 0? Can we be negative? No. So we're going to stop there because in context it doesn't make sense to go past 0. We could get a discount if we're 0 up to the age of 12, but not including 12. And or the word or if you are over 65. Now, we don't really have an upper limit to age. We all know that we can't live to 200, but it always seems like we find somebody else that's beaten the age thing. So we'll just kind of keep that going out there because we don't really have a defined limit on age. Now, because this is an or statement, in either you can be under 12 or you can be over 65. So you can't be both at the same time. Or doesn't require you to be both at the same time. Just one of them or the other. So that means that we have this region 0 to 12 together with, and we say union, that's what this U symbol means, union together with 65 and older. We'll put infinity. We know that doesn't make sense in this context, but can't really put an upper age limit. So that's how we write that in interval notation when we have this disjoint region where either one could be true because it's an or. So I want you to consider, before moving on to the next lesson, these two scenarios. And I want you to write a compound inequality, which means using and or. So you're going to write x is less than something and x is greater than something, or you're going to use the or. So that's what a compound inequality means. Draw a number line and then write the answer in interval notation. So just like we were doing above in these two scenarios. Bring these to class because these are going to be two scenarios that we work with before our next in-class investigation.